Hi, everyone. My name is Trent Fiero. I'm with Nile on the marketing side of the house. Today's session is about IoT. First off, I do want to thank you for joining us because I know that time is valuable. And we also know, though, that securing IoT is a big problem today. So thank you again for joining us. For the agenda today, what we're going to do is talk about the expanding use of IoT. We're going to look at, why IoT protection fails in a traditional network. And one of the things that, we do want to touch on the fact is that we're going to do a short little demo that shows you a matrix that's very valuable in building policies. We were at RSA recently in San Francisco, and a majority of people that we spoke to, when we showed them the dashboard, it was an aha moment because it's a very simple way to build a policy on what can reach an IoT device and what an IoT device can actually reach on a network. So my colleague Chris Liu, who heads up our product division here at Nile, will be talking and helping me out and touching on aspects of IoT and securing them within a Nile network. So we want to encourage, some collaboration. So if you have a question, I would appreciate you using the Q&A, or if you have something that you just want to ask, you can also use the chat functionality. I've also acquired a couple of gift cards to North Face. So I'm going to encourage people to join in if you're not a Nile employee or a partner and ask a question or share something about an IoT device that you think might be of value. And I'm going to selectively go through and randomly choose somebody to receive these gift cards. On that, let's start talking about securing IoT and why it's a constant battle. What we've seen over the last few years is a large number of devices that are being asked to be put onto the network. And the problem is that traditionally they can be small devices. They have very small, basic, operating system on them, very weak security. They're always connected to the network, so they don't come on and off like a laptop or a phone would. So they sit there. They're actually a well-known target for attacks. Um, from an IoT perspective, there's not a lot of functionality built into the traditional network on how to control these devices and protect them. So you're open to a variety of different malware, um, man-in-the-middle attacks, things of that nature. So what happens is you have people connecting these devices and you you're potentially fingerprinting them. Unfortunately, what happens is that a large number of these devices are unknown within the industry. So your access control solution may not be able to identify what it is. So hence you can't build a policy for that particular device. Which then leads into the idea of you get one out of three breaches today that's basically due to IoT and OT devices because attackers know that they're very vulnerable. And then the problem that extends once they get onto one particular device is that using lateral movement, they can move from one IoT device to another and then potentially move from segment to segment across your network. Um, on that note, let's move into looking at why traditional IoT protection fails. I'm going to have Chris, walk you guys through this potential, this slide so that we can cover things that we're seeing in the industry on legacy networks.
Great. Thanks, Trent. So first, we need to draw a clear line between the two very distinct worlds that coexist on your enterprise LAN, securing managed devices versus securing IoT and OT. For managed devices like corporate laptops, desktops, and servers, endpoint security using agents is essential. And we have EDR tools like CrowdStrike or Microsoft Defender that can provide deep host level visibility and give us that ability to react natively on the device itself. But IoT and OT operate in a fundamentally different way. Many of these devices simply cannot run an agent, as Trent mentioned. They can't be enrolled in standard IT management systems, and they certainly cannot be patched on a normal IT schedule. And that's why for IoT and OT, security essentially either lives or dies at the network enforcement layer. When we look at the traditional approach to securing these devices, there are several critical gaps that emerge. The first is the visibility gap. Many organizations struggle to confidently answer three basic questions. What exactly is connected? Where is it located? And what should the devices actually be allowed to do? Now, you might be thinking, doesn't my NAC solution handle this? Well, traditional NAC has major visibility blind spots when it comes to IoT and OT. First, it typically relies on MAC authentication bypass, which can be easily fooled by MAC spoofing. Additionally, traditional NAC is fundamentally a point-in-time check. It authenticates the device at the exact moment it connects, but it is largely blind to the actual application traffic flowing through the network afterwards. If an attacker spoofs a printer's MAC address, or if a real printer is compromised and starts scanning the network 10 minutes after it connects, traditional NAC won't see that. Right? It lacks the continuous traffic level visibility required to spot a device that's acting out of character. The lack of consistent and continuous visibility stems directly from the next issue, which is the no agent, no MDM reality. Because a large portion of our IoT and OT infrastructure can't run endpoint agents or be enrolled in MDM or UEM systems, we lose the standard controls we rely on for managed endpoints, and we end up dealing with black boxes on the network. The next critical issue is the traditional approach of managing risk through VLAN-based network segmentation. VLAN-based segmentation creates a false sense of security by creating broad implicit trust zones. Once an IoT device connects to its assigned VLAN, it can often see and reach far more than it actually needs in order to function, which violates true zero trust principles. This leads directly into our next major issue of overly permissive access policies. In traditional environments, rules are defined between VLANs using ACLs, which inevitably end up being too broad. What Zero Trust mandates is a least privilege approach, where a specific device class is only granted access to the exact services it requires and nothing else. Trying to build least privilege rules using VLANs can result in massive VLAN sprawl. It also forces your security and network teams into a tight operational bottleneck where one can't move without the other. If security ops wants to further segment devices or lock down a compromised camera, they have to wait for a network engineer to create a new VLAN and rewrite ACLs. That operational friction means security operations can't quickly adapt to the needs of the business without getting the network operations teams involved. Finally, we have to consider threat and breach containment. When an IoT device is compromised or exhibits suspicious behavior, time is of the essence. Unfortunately, in legacy networks, quarantining a device often requires disruptive network changes, specifically moving a device from one VLAN to another, which involves multiple steps. This process can be slow, inconsistent, and highly dependent on exactly where the device is connected. Using an overlay NAC to address quarantining is complex and brittle and relies on a fragile security control plane, such as sending COA messages or scripting in order to tell the network what to do. And this brittle control plane between detection and enforcement functions is what leads to non-deterministic or best effort results right when you need containment the most. And when you're dealing with fast-moving threats like ransomware attempting to move laterally from a compromised IoT device like a camera to a critical server, this window of exposure is important. A manual or automated but non-deterministic containment process is exactly the wrong thing to rely on. So what do all of these gaps lead to? Well, the combination of these issues is what makes unchecked lateral movement possible in traditional networks, which can lead to larger than expected blast radius, both of which can have significant impact on business risk. In the world of IoT and OT, where agents are generally not supported, the network itself must become the security enforcement point. And the ideal location to gain the visibility, the identity context, and enforcement capabilities needed to secure unmanaged devices and systems without relying on out-of-band or overlay solutions like NAC. So with that context, I'll turn it back over to you, Trent.
Well, actually, I have a question, Chris.
Hmm.
So there's a lot of issues here, right? Why do people still run into problems? I've seen other vendors suggest SSE, ZTNA, um, dynamic segmentation. What's the actual problem with that?
There's a lot of issues you touch upon there, Trent. The one we're referring to here about IoT and OT is a lot of times these systems can't host the agents. So when you look at some solutions like SSE, which require hosting an agent, that works for managed devices and users, but it won't work for the IoT and OT environment. A lot of the OT systems run legacy protocols. IoT systems, as you mentioned, have limited capabilities to host agent capabilities. So that's where you really need to have the network perform the network enforcement functions on behalf of those unmanaged devices.
Yeah, and then I was also told that because of this limited software set on a lot of these devices, um, not a camera, but let's say a small little sensor may look like something else because it's basically running, the same software set. There's not enough differentiation within that particular identifier to say, okay, that's a sensor for the vape sensing versus one for shot detection. So this visibility gap's a big problem, and that's why you end up with the unknowns, correct?
Right. And that's why you need to have the embedded fingerprinting capabilities to accurately identify these devices that are connecting to your network. The network should have full 100% visibility to all users and devices that are connecting to that fabric. And we're going to touch upon that in a little bit later in this webinar.
That makes a lot of sense. Thank you.
Mhm.
So on that, we were transitioning and we're saying, okay, look, you've built out a network, and what you've been asked to do is bolt things on. So if you look at the left-hand side, NAC solution, you bolt on in order to do colorless ports. You do that to do dynamic segmentation. You do that to push policies across a large environment. And unfortunately, what you have to do is set it up for one location and then do it again for the next location and whatnot. So then they start asking you to do VPN, VXLAN, more complex, functionality that requires time, resources, and money. Um, if you're looking at, legacy wireless and legacy switches, again, I think Chris alluded to the idea of using VLANs. While VLANs are great to break up a domain, they're not really good at containing malware because you've got multiple devices within a VLAN. If one device is compromised, it compromises others. And then from operational complexity, what we're looking at is, again, low visibility. If I'm fingerprinting, but I'm not really getting a good picture, and the idea is letting a device onto the network as an unknown, I can't create a policy. So I've got poor security posture and compliance. I've got policy spaghetti because I'm building policies on the fly. And if you've ever used a NAC solution, they're rather complex. What we said at Nile was, let's do this differently. Let's build zero trust into the fabric. Let's make sure that there's a standardized and very deterministic way in which to enforce security, and then let's deliver it as a service. So if you go this route, you end up with high-end Wi-Fi, high-end switching, built-in security, um, isolation by default, micro segmentation. It's all there for you on day one. Any insights, Chris?
Yeah, I think what you described there is a secure by design approach, and it's a fundamentally different approach to implementing networking and security as the integrated solution. And we're going to dive into that in our next slide.
Perfect. Take it away, Chris.
Okay, so Nile has a universal five-step progression for implementing zero trust and protecting all users and devices in the enterprise wired and wireless LAN. But what I'm going to do is focus on how this applies to protecting IoT and OT specifically. So, as Trent mentioned, IoT and OT are ideal targets for bad actors because they're often blind spots for IT organizations. So, ensuring a true zero trust environment for them really requires the network to step up and be the security enforcement agent. And the first step for achieving that is in terms of protecting IoT and OT, is gaining that 100% visibility that we were just talking about earlier, because you can't protect what you can't see. Many organizations think they have an accurate inventory until they look closely. And with IoT and OT, the problem is that many devices aren't registered in an endpoint management system and thus not managed via agents. So visibility has to be agentless, and it has to be accurate enough to drive policy, not just to be able to create a list of items. And just as important, visibility has to be continuous. It's important not only to identify the device at the time it joins the network, but also to continue verifying its identity on a continuous basis, monitoring its behavior, looking out for anomalies, and determining if there has been any potential drift with respect to its fingerprint identity. So the takeaway in this first step is you must have 100% visibility. Without it, zero trust can't even start. The second step is about explicit verification. All IoT and OT systems must be authenticated onto the network and approved before any communication is allowed. And this is where zero trust really starts to feel different from traditional networking. In a traditional network, an IoT device plugs in and it just starts talking, right? Maybe policy gets applied later, maybe it doesn't. This conventional plug and play model is exactly what Nile Zero Trust is trying to eliminate. The Nile model is secure first, communicate later. At the physical layer, every port is secured by default, eliminating open ports and plug and play as potential attack vectors. This is coupled with strict approval requirements for any user or device connecting to the device, to the network, whether it's be through fingerprint classification, context, or device validation. Now also enforces strict authorization before communication. IoT and OT devices are not permitted to send traffic until an explicit policy is in place that allows it. Now, Zero Trust doesn't end after initial verification and authorization. While the device is on the network, it's crucial to continuously evaluate the trustworthiness and posture of that device on an ongoing basis. Now supports this using continuous validation by constantly monitoring the behavioral fingerprint of the device and actively checking device credentials. The fabric ensures an IoT device, like a printer, hasn't suddenly started acting like a laptop and verifies that it's a corporate managed device. This helps prevent rogue or uncompromised devices from remaining unchecked on the network where they can do harm. And any device that doesn't meet the continuous validation check is identified as non-compliant and can be quarantined immediately to restrict its access. Now, the way Nile handles quarantining is highly differentiated and worth a quick mention. Because Nile's security policy works as an overlay, it operates completely independent of the underlying topology. This means quarantining is driven entirely by software-defined policy reclassification, not through disruptive network changes. The security policy follows the identity of the device no matter where or how it's connected. If a device fails a continuous validation or compliance check, the fabric instantly reclassifies it into a quarantine policy group. So what does this mean for customers? Well, it means it's fast, deterministic threat containment. You're no longer relying on brittle, best effort COA messaging or VLAN reassignment or IP subnet changes. Instead, you get instant threat containment without dropping the device's connection state, reducing complexity and delivering a win-win for both the security and network operations teams.
Is complexity the reason why you hear people they want to do posture checks and
Mhm.
they jump into it, but they never really complete it? Is it just because of all the interaction that you have to, set up with all your switches and then all your wireless devices? Is that it?
A large part of it is due to the complexity of trying to integrate multiple discrete systems together to come up with a comprehensive solution. Right? And this is an artifact of the method of trying to apply security solutions on top of networking. Right? The whole industry was built around networking, providing plug and play services, and then security products and solutions were introduced later. And that's what's creating that stacked solution on the slide that you showed earlier. And that breeds complexity. And with each system that you add, it takes a lot of effort to maintain that integration integrity over time. So yes, a lot of that, what you're mentioning there is due to the fact that it's difficult to manage multiple systems with independent lifecycle solutions as an integrated system.
I'd also like to revisit the continuous validation. Earlier today, I was actually on a call with an analyst, and he wanted to understand why it doesn't really work in a traditional network versus how Nile's doing it. So if you can provide some insight on that, that would be great.
From your analyst discussion?
Yeah, yeah.
Oh,
Well,
okay.
the idea being that, why can Nile do continuous validation versus, the traditional network? Why isn't it easy?
Well, again, it comes to having in the Nile solution, the capability is built into the fabric itself. All these capabilities are native to the Nile solution, and by eliminating the need to have external systems be layered on top of or integrated, makes this whole process of continuous validation much simpler. We have the built-in fingerprinting, we have the built-in DPI capabilities, we have a lot of integrated technologies that are part of the zero trust fabric itself that just inherently makes the continuous validation much simpler for us. And it's also because we have full visibility not just to the identity of the devices and users, but also full access to all the traffic flows that are traversing the fabric. And we can monitor and detect these anomalies native to the solution.
I think that's what I told him. You might have said it a little bit better than I did. But what I gathered was built-in is better than bolted on and out of band, right? Um,
Exactly.
okay,
That's
perfect.
right. So just to continue on, the next step in this progression is isolation. This is the step that prevents one compromised IoT or OT device from essentially becoming an incident that ends up in the news. Compromised IoT and OT devices are dangerous when they can discover or interact with other devices, such as through broadcast discovery, lateral probing, or shared visibility. And that's how small compromises snowball into major business impacting breaches. In Nile's zero trust solution, isolation of every endpoint into its own segment of one is the default state. Instead of the traditional approach of using a VLAN to fence in all of your IoT devices, where lateral movement can occur unchecked, now gives each device its own private fence the moment it connects. By default, the device cannot see or discover anyone else on the network, which eliminates lateral movement. The gate is only open when access is granted explicitly. And this is the baseline behavior in Nile's zero trust solution. Once the device is isolated, the next step is to let the IoT or OT device do its job, but to do so safely in accordance with zero trust principles. Most IoT and OT devices have very predictable communication needs. They talk to a controller or a management system, maybe a specific cloud service. Anything beyond that is usually unnecessary risk. So instead of an open policy like IoT VLAN can access everything it might need, now employs an explicit identity-based least privilege access model that defines precisely what it should be allowed to access. So, for example, cameras can talk to the video management system over these services, or a badge controller can talk to the building access control server using HTTPS only. That's what least privilege means in practice. Explicit, fine-grained policies, not broad trust zones or overly permissive access. And when they are identity driven, the policies remain consistent even if the underlying network changes because the intent isn't tied to VLAN placement or IP addressing. This is where zero trust shifts from a device merely being isolated to a device now being productive by applying explicit policy to enable the device to securely do exactly what it should be doing and no more. Finally, the last step is about consistency and extending zero trust policy across all environments. We call this universal zero trust. It means having the same policy intent and enforcement model across the environment. In some organizations, certain IoT or OT devices might require access to cloud-based services for management, analytics, or updates. When that's the case, Nile solution can easily forward outbound micro-segmented traffic to SSE platforms for cloud-delivered inspection without weakening local isolation and identity-based access. The device still remains contained and protected locally while its internet destined traffic gets handled appropriately. So with that, I'm going to turn it back over to you, Trent.
Thank you. So we're going to switch screens real quick. Chris is going to take over and provide that demo that I was talking about earlier. While he's doing that, I do want to ask if you have a IoT story that you'd want to share, and add that to the chat. I would appreciate it. I have one of my own. We were working with a school. They used a TV in the lunchroom, and they wanted to show the kids what they were going to have for lunch. After a while, nobody really wanted to manage it. The TV sat on the wall. Few months later, it turns out that that TV was talking to websites in Russia, a variety of different countries that it wasn't supposed to be. Again, because IoT devices are typically unmanaged, they don't really belong to a specific person. They're always on the network. Attackers know that they're an easy target. So something like that you have to really pay attention to because you don't have you don't have the hard controls that you really want out of your traditional network. Um, Ready to go, Chris?
Okay, so what I'm showing here is the policy matrix that Nile has as part of the Nile portal. And this is basically a simple representation of who can talk to what. We organize the policy matrix based off of policy groups. Policy groups are essentially security perimeters that are logically defined in software that associate endpoints together based off of various different match criteria. For example, we can use identity as a way to group all contractors or employees together. Or we can use device fingerprint to group together cameras or what else do I have here? Building access controllers. So it's important to note a policy group is not a trusted group, right? Just because two devices belong to the same policy group, because we have host-based isolation, we prevent them from being able to talk to each other. So what this matrix is showing is the relationship between source policy groups on the y-axis and destination policy groups on the x-axis. And where you see a colored icon like a green checkbox or red X, that indicates the presence of an explicit policy, either explicitly allowing the traffic or explicitly denying the traffic. And where you see these gray circles, that means there's no policy that exists or hasn't been defined between those policy groups. But because Nile adopts a default deny posture, no traffic is permitted by default wherever you see these gray cells. So let's just dive into two quick examples here. I'm going to dive into the policy that's showing a building access controller talking to a building access server. And what you see in the definition of a policy shows how easy it is to represent a policy for IoT and OT devices. What this is saying here is I've defined a source device policy group called building access controller. And there's a policy to the destination policy group, which is an application group. In this case, the building access server is specified using a specific IP address. This could be located, for example, in your data center. You can see on the source policy group, we're using device fingerprinting to identify these building access controllers. And the service profile is defining what specific protocols and destination ports are allowed for this specific communication. Okay. So nowhere do you see when you're specifying a policy, they need to specify ACLs or IP addresses, right? We're using these identity-based policy groups as a way to construct policies. As another example, I can show between IoT and IT admins talking to printers, right? You can see this policy here that I've constructed classifies IoT and OT admins based off of a network segment that they're logging into. And for printers, in this specific example, I could use device fingerprinting, but maybe I wanted to create a policy to a specific set of printers based off of MAC or OUI addresses. So it's very flexible in terms of how you classify devices together, either by fingerprinting or by specific MAC OUI or IP addresses. And what we're defining here in the service profile is the specific set of ports and protocols that IoT and IT admins are permitted to use to printers. This is how you can create policies to, for example, allow faculty to access printers, but not be able to access the administrative ports of printers. Maybe you want to reserve administrative port access only for the IT admins. So that's how simple it is to create policies here.
So, Chris, I've seen you build a policy before. It took a little less than 3 minutes or so. If I was using a traditional NAC, device appliance, how long do you think it would take me to build something like this? A simple policy.
Well, it could take, I mean, once you've got everything predefined in NAC, defining the policy itself may not take too long, but the challenge is in terms of the whole integration effort of tying the NAC as an overlay system onto your existing infrastructure, maintaining it over time, right? NAC has solutions and vendors typically will have their own life cycle costs associated. We have to deal with upgrade cycles for your infrastructure, upgrade cycles for your NAC. You'll need dedicated people who are trained up on the NAC solution itself. Right here in Nile solution, all the NAC functionality is already built into the fabric itself. We don't have a NAC product or NAC offering. The NAC is an integrated service as part of the whole NAS service that Nile offers. So there is no learning curve here, right? Because there's no product that you need to manage and maintain independently. It's just a built-in capability as part of the service.
That's pretty nice.
Yeah. So just last part of the demo, I'll just show how quickly it is to create a policy. Say I do want to now enable faculty members to access the printers. I'm actually going to click on the gray box there to add the policy. And here I specify the policy name. Maybe it's faculty printer access. Just call this new policy for now. Once I filled in the metadata, the wizard has already pre-selected faculty and printers as the source and destination policy groups. Right? And if I'm satisfied with that, I can just go ahead and continue on to the next step. The third step here is basically defining what action you want to support for this specific policy. I can allow the traffic to be natively permitted through the Nile Zero Trust Fabric, or I can explicitly deny it if I want to block it and have it be recorded in a policy log. Or if you want, you can also forward it, right? If you want, you can forward the specific microsegmented traffic to an upstream system or to an SSE partner. In this example, I'm just going to allow it because many of our customers are looking to have Nile natively enforce the east-west traffic. And here I can select a specific service profile I want to associate for this faculty printer policy. So here I've got a predefined printer profile, if I expand on what this policy is now looks like, it's telling me any member of the faculty, and we're identifying faculty members in this specific use case based on what network segment they're connected to. Um, can talk to printers. In this case here, the printers are being identified based off of collection of MAC addresses or OUI information, but we can very well easily classify printers by device fingerprints, like I showed in the earlier example. And then finally, the printer profile. And here I'm only allowing the uh, protocols and ports to allow the faculty members to discover the printers and to be able to forward print jobs to the printers. So with that, I can confirm the policy and then hit update. And then you can see the policy instantly appears. And here it is, right? Between faculty and printers, I now have a pre-built policy. And this immediately starts getting enforced within the Now Zero Trust fabric. Because I've specified it as an allow policy, there's no need to communicate with an external or upstream firewall for that enforcement. Okay, so that's how
I,
simple it is to
yeah.
support policies.
I want to thank you for keeping me honest. It was under 3 minutes, and that's with you describing every step along the way.
Yeah,
So
you
if I
can.
was like used to the system, I could probably do it in a minute or so.
That's right. And the important thing again is I can define any new policy I want without having to go back to the network operations team to tell them, hey, can you create a new VLAN for me or can you change the ACLs? Right? Because the security control plane in Nile operates independent of the network topology.
And there's no building roles, tying roles to the rules. And yeah, this is super simple.
Yeah, great. Okay, back to you, Trent.
Perfect. So why Nile? It's basically simple. Well, actually, what we call the five S's. You've got security that's built in. We've taken a lot of different components that you have to add on to a traditional network, and we've eliminated those. We've built a lot of functionality into the network itself. So with simplicity comes, fewer trouble tickets, fewer complaints, fewer issues that are intermittent. It's all built into the system again. Speed means that you can accelerate your business objectives. Um, a lot of people always ask us, why zero trust built into the network? Many times it's the fact that they go down the path of adding more security onto their network. They run into integration issues. They run into cost issues. Um, at RSA, I think I saw 300 booths where people were trying to sell you something to add on to a network to better protect your network. At Nile, we're saying we've already built it into the network so you can reach and achieve zero trust much quicker. The cost savings comes in a variety of different ways. Um, there's IT resources, there's add-on solutions, there's integration effort, a variety of different things that basically, if you go the Nile route, will help you save time and money. And then the last thing is an SLA. Going down the Nile path means that you have an option to get a service guarantee. So from a performance standpoint, you have users that are getting better application responsiveness. You have way better uptime. You have the ability to check your network all of the time with automated automation that goes in and optimizes your environment for you. So it's not a lot of manual effort and screen time. It's just a different model and different way to approach your network today versus going down the path of buying the traditional network and maintaining status quo. Anything to add, Chris?
No, I think you've captured all the key points, right? The Nile offering as a service means we can offload all of those typical life cycle and operational costs associated with managing that physical infrastructure, managing those security systems and solutions by yourself. So I think you've summarized it very well, Trent.
Perfect. Thank you.
Yeah.
So The next webinar that we're going to be talking about in May is all about an introduction to Nile secure guest access. It's different again than anything else in the industry because you're taking advantage of what we've built into our Zero Trust fabric. You've got the isolation of all devices. You're not placing guest devices into a VLAN. So there's no VLAN snooping. There's no ability to take and put malware on one device and have that hop from device to device. It's a a way better solution for introducing guest into environment or just delivering guest in any type of environment that is way more secure. There's no OWE. There's nothing that you have to add special onto the network. It's just supported by now by default. And on that, I want to thank you again very much for your patience and your attendance and sharing time with us. And again, have a good day and thank you very much. See you, Chris.
Yeah, bye.
Take care.